Good day everyone! Welcome to our online math tutorial series of math lessons for grade 10. Tara, sabay-sabay tayong matuto at home. This is for grade 10 mathematics, quarter 1, module 7, all about geometric series. I am Ms. Marian M. Guerrero, your teacher for today. Before we start, please prepare the following: your math module, piece of paper, a pen, and your notebook. In this lesson, you are expected to find the sum of terms of a finite geometric sequence and find the sum of terms of infinite geometric sequence. As we start, let us have a quick recall of what we have discussed from the past modules. A geometric sequence is a set of terms in which each term after the first is obtained by multiplying the preceding term by the same fixed number called the common ratio. And the common ratio is obtained by dividing a term to its preceding term. To start with, let us have first an activity entitled Class Factor. Find the next two terms of the geometric sequence and find its sum. Number 1, 7, 14, 28. For us to get the next term, we have to get the common ratio. And common ratio is obtained when we divide the second term to its first term. 14 divided by 7 is 2, and also 28 divided by 14 is 2. Given that the common ratio is 2, we will now multiply it to the last term given. Thus, 28 times 2 will give us 56, and 56 times 2 is 112. Now, we have to find the sum. So when we add all these terms in the sequence, then its sum will be equal to 217. Number 2, 3, 12, 48. Let us get the common ratio by dividing the second term to its first term. 12 divided by 3 is 4, and 48 divided by 12 is 4. 48 times 4 will give us the next term, which is 192. And 192 times 4 will give us 768. Adding all the terms in this geometric sequence, the sum now will be equal to 1023. Next, number 3. We have 400, 200, 100. The common ratio is obtained when we divide the second term to the first term. And 200 divided by 400 is 1 half. Multiplying it to the last term given, 100 times 1 half is 50, and 50 times 1 half is 25. Now, adding all the terms in the sequence, we have the sum of 775. We were able to get the sum of the geometric sequence. Well, how about the sum of the first 20 terms? Or 50 terms? Or even 100 terms of a geometric sequence? Are you still going to generate all the term, then get its sum? To answer that, let us now have our lesson. Our first lesson is all about finite geometric series. A geometric series refers to the sum of terms of a geometric sequence. For example, in the given example a while ago, we have 7, 14, 28, 56, 112. When we add all of these terms, the answer is 217. And 217 is what we call the geometric series. It is the sum of the first 5 terms of the geometric sequence. We are now given the formula in finding the sum of the first n terms of a finite geometric sequence. It is given by S sub n is equal to a sub 1, quantity 1 minus r raised to n all over 1 minus r. Wherein S sub n is the sum of the first n terms, a sub 1 is the first term, n is the number of terms, and r is the common ratio. Our first example. Find the sum of the first 7 terms of a geometric sequence whose first term is 3 and common ratio is 4. Using our formula, we have to get all the given values. Our a sub 1 is equal to 3, our n is equal to 7, and our r is equal to 4. Let us substitute this to our formula. This will become s sub 7 is equal to 3 quantity 1 minus 4 raised to 7 all over 1 minus 4. Now, let us simplify the exponent inside the parentheses. That is 4 raised to 7, that is 16,384. And for the denominator, 1 minus 4 is negative 3. Then, let us divide 3 and negative 3 from the numerator and the denominator. This will become negative 16,383 divided by negative 1. And now, the final answer is 16,383. Therefore, the sum of the first 7 terms of the geometric sequence is 16,383. Have another example. Find the sum of the first 6 terms of the geometric sequence 1/4, 1/2, 1. Let us state the given. We have a sub 1 be equal to 1/4. N is equal to 6 since we are looking for the first 6 terms. And the common ratio is 1/2 divided by 1/4, which is 4 over 2. Simplified it, the ratio is 2. Using the formula, we will substitute it to our sequence. We have s sub 6 is equal to 1/4, quantity 1 minus 2 raised to 6 all over 1 minus 2. Then, simplify the exponent. This will become 1/4, quantity 1 minus 64 all over negative 1. Then simplify. We have s sub 6 is equal to 1/4 times negative 63 all over negative 1. And simplifying, we come up with s sub 6 is equal to 63 all over 4. Therefore, the sum of the first 6 terms of the geometric sequence is 63 all over 4. Let us now have a problem. Joey saves an amount in his bamboo bank each week. To make it fun, he doubles whatever amount is inside the bank during the next week. On the first week, he saves 1 peso. On the 10th week, how much will be in the bamboo bank in all? This will be the representation of the problem in a table. Wherein, the problem asks us to compute for the total savings on the 10th week. Thus, we have to compute for S sub 10. Table will come up with the sequence 1, 2, 4. And we are looking for the sum of the first 10 weeks. Therefore, we have here a sub 1 or the first term is 1, n is equal to 10, and the common ratio is 2. Using our formula, substitute all the given values. S sub 10 be equal to 1, quantity 1 minus 2 raised to 10, all over 1 minus 2. Then simplify the exponent, expand 2 raised to 10. This will become 1 times 1 minus 1024 all over negative 1. Simplifying it, we have S sub 10 is equal to negative 1023 all over negative 1, and that is S sub 10 is equal to 1023. Therefore, Joey has a total savings of 1023 pesos after 10 weeks. Now we are done discussing the finite geometric series. Let us now have our second lesson, the infinite geometric series. Task: find the sum of the terms of the geometric sequence 1, 1/2, 1/4, 1/8, 1/16, and so on. Is it possible to get the sum of terms of an infinite geometric sequence? To answer that, let us have the activity. Let us consider the figure below. We have here 1. This represents 1. And half of it is 1/2. Half of 1/2 is 1/4 represented by this yellow block. And when we divide it to 2, we have 1/8 represented by this gray block. And then half of 1/8 is 1/16. which is in the orange block. And then we have 1 all over 32, 1 all over 64, and so on. If you notice, these are terms in a geometric sequence wherein we have 1, 1 half, 1 fourth, 1 eighth, and so on, with the common ratio of 1 half. When we get the sum of this term, this block, which is 1, is equivalent to the other blocks here. Note, meaning, when we add this, we have 1 plus 1 half plus 1 fourth plus 1 eighth, and so on. That is equal to 2 blocks. With that, meaning, it is possible for us to get the sum to infinity of a geometric sequence. And for us to get that, we can use this formula. Sum to infinity is equal to a sub 1 all over 1 minus r, wherein a sub 1 is the first term and r is the common ratio. But note that the sum to infinity of a geometric sequence is only applicable when the common ratio is greater than -1 but is less than 1. For example, find the sum of the terms of the infinite geometric sequence 3, 1, 1/3. Using our formula, let us first state the given. We have the a sub 1, which is the first term, that is 3. The common ratio is 1/3. 1 divided by 3 is 1/3. And let us now use the formula and substitute our given. We have sum to infinity be equal to 3 all over 1 minus 1/3. Let us simplify the denominator of the fraction. We'll come up with sum to infinity is equal to 3 all over 2/3. Simplifying it, we have sum to infinity is equal to 9 all over 2. Meaning, the sum to infinity of the sequence is 9 all over 2 or 4 and 1 half. Let's have another example. Find the sum of an infinite geometric sequence whose first term is 5 and the common ratio is 1/4. Let us state the given. A sub 1 is equal to 5 and r is equal to 1/4. Using the formula, let us substitute all the given values. We have sum to infinity is equal to 5 all over 1 minus 1/4. Simplifying the denominator, we have 5 all over 3/4. And then simplifying again, we have sum to infinity is equal to 5 all over 1 times 4/3, which is equal to 20 all over 3. Therefore, the sum to infinity of the sequence is 20 all over 3 or 6 and 2/3. That is all for today. But before that, let us have a synthesis. The formula in finding the sum of the first n terms of a finite geometric sequence is given by S sub n is equal to a sub 1 times 1 minus r raised to n all over 1 minus r. And the formula in finding the sum to infinity of a geometric sequence is given by sum to infinity is equal to a sub 1 all over 1 minus r. That is all for today. I hope you've understood our lesson. Thank you for listening.